here's how to make a cavity milling toolpath. For our example, we'll go ahead and rough the top of this part down to the floor of this circular pocket. So we'll go ahead and go to Create Operation, to the Mill Contour type, and select Cavity Mill. We'll go ahead and just use our quarter flat end mill for this demonstration. Say OK. Now we're in the cavity milling dialog box. So you can see this is all the predefined stuff that you just set in the create operation. Here we can specify a cut area if we only specifically want to cut a certain spot. Here you can see your check coming from your geometry in your workpiece. Here you can set a trim boundary or like a containment boundary, so the tool can stay within that boundary or outside of that boundary. We have our tool axis. In this instance, we're going to go ahead and just cut straight down from the Z axis. And then our path settings. There's multiple cut patterns that you can choose. I like the follow periphery pattern for a traditional roughing. Our step over, percent of flat, our percent of flat diameters, keep that at 70%. And then our depth of cut is set to 200 thousandths. Being that we used a 1/4 inch end mill, I'll go ahead and drop this down to 50. Next, we'll go into our cutting parameters, and we will go ahead and set our ranges. So up here in containment, the in-process workpiece, you can set this to use 3D if there's already toolpaths in your program that you want this to look at. So for instance, if you had already previously roughed part of this top with a larger tool and then wanted to come back in with a smaller tool to pick out the areas that the large tool couldn't get into, if you check this use 3D or set the use 3D, it will then look at the previous toolpaths and not cut air. In this instance, we're going to make it out of just the raw block chips, so we'll set that to none. We'll keep our range type as automatic. Top of our range will be the top of our part, as you can see highlighted there. And then in our range definition, if you expand on your list, this is going to show you all of the depths that it's going to cut at. So I'm going to go ahead and eliminate some of these because we only want to cut down to this floor. But to add a new depth, simply just click Add New Set and then pick somewhere on the part and it'll add that depth. There's an extend option if you wanted to extend the path. And that is going to be about it for right now. So we'll go ahead and say OK here, and we're going to generate this toolpath. As you can see, it roughed it out. So we'll go ahead and move this to the top and verify. And then you'll be able to see that we went ahead and just roughed away all of this material down to that floor level. Now you'll notice that all of these levels where it's blended out and faceted between the blue and the purple, those are all finished material. That's because we don't have any stock to leave on our toolpath. If we go back into our cavity milling toolpath, on our main tab, there's going to be a part side stock category here, and there's going to be this checkbox to use floor same as side. If you uncheck that, it'll give you an option to make the floor stock different. If you have it checked, it's going to just use 1. Since we're roughing, we'll go ahead and add 30 thousandths here for the walls and the floor, and then we will regenerate. Now if we verify this toolpath, it'll look a little bit differently. And you'll notice that now there's material left everywhere. It's no longer blended out, other than the top that we had our face milling toolpath finish. One other option, you can use a containment boundary. So if we open up our cavity milling, we'll go ahead and click off of that guy. And we can go to our specified trim boundaries. Now you'll notice here that this toolpath is still visible. That can be a little bit annoying sometimes. We can click off of it, go away, and then sometimes it stays, sometimes it doesn't. But we can see this box here that says display toolpath. If you select that, it'll turn it off, and then when you go into it, it won't display. So for specify trim boundaries, this is how we're going to add a containment boundary. We'll go ahead and say we only want to cut inside of this circle. We'll go to our curves, and we will select this circle. If your side trimmed is set to inside, it's going to cut on the outside of your boundary. If it is set to outside, it's going to cut on the inside of the boundary. It's going to do different, but it says side trimmed. You're trimming away the outside, so it's going to stay on the inside. We'll go ahead and set our boundary and then specify a plane. This is a good habit to get into. That way it snaps this curve you selected to that plane to make sure it's looking at the boundary from the correct angle. We'll go ahead and say okay there, okay, and generate this again. Now you'll see that it only cut inside that circle. There is one overlapped path here, if we verify, where you'll see that it actually does cut over the top of the chamfer. If you want to eliminate that, you need to open the toolpath and add trim stock of half of the diameter of your tool, or the full diameter of the tool, depending on how much you want to trim away. So if we add a 1/4 inch there, since we're using a 1/4 inch end mill, and generate once again, you'll see that it clearly now stays inside of the boundary. We can go ahead and remove that, and then remove our trim boundary, and do one more example here where we use a cut area. For the cut area, if we drop this down here and select tangent faces, we can click on the inside of this feature. So by selecting that circular pocket feature in that chamfer, we can say okay. Now notice there is no trim boundary here because there's no eye to display. We can say okay again, and then if we generate, it's going to give you a similar result as to the trim boundary function. There are many different ways to be able to handle how you do a cavity milling toolpath. There's no perfect way to do it. It's a lot of personal preference, and it just depends on what works best for you. But by manipulating these options, you can get a cavity milling toolpath to do whatever you really want in regards to roughing out a part.